So looking at asymptotes of rational functions, let me get a graph real quick to show you what we're actually finding. So here is an example of a graph of a rational function, and we can see that there's places both vertically and horizontally that our graph skates very close to, as either the x values go out to positive or negative infinity, or the y values go out to positive or negative infinity. This vertical line that causes my graph to kind of in the opposite directions is what we call a vertical asymptote. And this vertical asymptote, the vertical asymptotes come from the factors of the denominator that can't be canceled out. And we'll look at an example in just a second. But the horizontal line that again will make my graph off to the sides, we call the horizontal asymptote. And the way we find out what the horizontal asymptote is based on the exponent, the highest exponent, or the degree of the polynomials in the denominator and the numerator, how they compare to each other. So let's first look at finding the vertical asymptote. So this is very similar to finding the restrictions on the rational function, but we do have to take into account any factor that would cancel out. If a factor cancels out, then it doesn't create an asymptote, it just creates a hole. And if we're just trying to find the asymptotes, then we don't need to worry about that place. So let's look at an example real quick. All right, so let's say I have x squared plus 3x minus 4 and x divided by x squared minus 2x plus 1. So to find the vertical asymptotes, I'm going to write both the top and the bottom in factored form. These turn out to be quadratic, so we can just factor them. The numerator, x squared plus 3x minus 4, if I multiply x times x, I'll get x squared, and positive 4 and negative 1 multiplied together will give me negative 4, and when I add them together I get positive 3, so there is the numerator factored. And in the denominator, if I multiply again x times x, I get x squared, and if I do negative 1 times negative 1, that gives me the positive 1, and if I add them together, I get the negative 2. So these are the factored form of my rational function, and we can see that both the numerator and denominator have a factor of x minus 1. This x minus 1 would create a hole, and we're not trying to find any holes right now. We're just trying to find vertical asymptotes. So I'm going to cancel out any factors they have in common. Whatever is left, I'll use to find the asymptote. Same exact way as we did finding the restrictions on the rational function. I'll take whatever's left in the denominator, set it equal to 0, and solve. So x equals 1, just adding 1 to both sides. X equals 1 is my vertical asymptote. Squeeze it in right there, my vertical asymptote. So if we were to graph this, then at 1 on my graph, I would have this imaginary little dotted line right here that makes my graph go like that. There's my vertical asymptote. Now, sometimes when you factor out, they won't have anything in common, and that's totally fine. Nothing will cancel out. So you could end up with 2 vertical asymptotes or 3 vertical asymptotes, depending on what the denominator looks like. And it's even possible not to have any vertical asymptotes at all. So this is an example of how to find it. Just make sure if there's anything that can cancel out from the factored form, you cancel it out. Whatever is left, you set equal to 0 and solve, and that's how you'll get your vertical asymptote. So how do we come up with our horizontal asymptotes? So like I said previously, determining what your horizontal asymptote is comes down to the degree of the polynomial in the numerator and the denominator. So we could have 3 different situations. I'm going to write them all out real quick. All right, so as far as the degrees or the highest exponent for the polynomials that make up the rational functions, there are 3 possibilities. So if you look at the degrees of the polynomials that make up the rational function in this first example right here, in the numerator we have a linear function, so this is x to the first power. And in the denominator, we have, again, a linear function. So its degree is 1. This is x to the first power. When we have the situation where the degrees are the same, so same degree, we have a horizontal asymptote. So HA, our horizontal asymptote, will be y equals the ratio of the leading coefficients. So if you look in the numerator, my leading coefficient, the number that's with x to the first power, is 3. And in the denominator, my leading coefficient is just 1, the number that's technically in front of x to the first power. So this would be 3 over 1. So my horizontal asymptote, I can simplify that as just y equals 3. There's my horizontal asymptote. Notice if this rational function had been flipped, if it were x minus 5 over 3x plus 2, let me go ahead and write that out. If it were this, we can see still that they have the same degree. They're still to the first power. So my horizontal asymptote would still be the ratio of those leading coefficients. But now the top, the leading coefficient is 1, and the bottom is 3. So my horizontal asymptote would be y equals 1 over 3. So it's always just the ratio of the leading coefficient from the top over the leading coefficient on the bottom. All right, so case 2. Think about real quick what the degrees of these polynomials are. So in the numerator, we have a constant, which is technically x to the 0 power. And in the denominator, we have a quadratic, so x to the second power. Notice here that the degree of the polynomial in the bottom is bigger than the degree up top. Anytime this happens, our horizontal asymptote is automatically y equals 0, as long as the degree in the bottom is bigger than the degree in the top. So let's look at another example real quick. Something like this. So now in the numerator, I have a linear equation or a linear function, which is a polynomial, to the first power, and in the denominator I have a quadratic, which is a polynomial of degree 2, right? Still, the degree of the bottom, my denominator, is larger than the degree up top, so I fall under the category where automatically my horizontal asymptote is y equals 0. So in the third situation, you might kind of see the pattern here now. In the third situation, the degree up top is larger than the degree on the bottom, right? I have a quadratic, which is a degree 2 polynomial, and in the bottom I have a linear function, which is a first degree polynomial, anytime the degree is larger in the top than it is in the bottom, we end up with no horizontal asymptote. We actually have what's called a slant asymptote. And in order to find that, we would have to know how to do polynomial division, which